So this is just a little bit of practice evaluating one-sided limits when you don't have a graph available just to look at it. For this first problem, your first step, and always the first step, is just to plug your number in. So 2 plus 1 is 3, and 1 minus 1 is 0. Well, there's a clue. I have an asymptote at 1 because 3 divided by something really, really, really small is something really, really huge. So I'm going to put an infinity. I need to check and see if this is a positive infinity or a negative infinity. So for this, we're coming into 1 from the right-hand side. So I'm going to pick a value like 2. 1 minus 2 is negative. So now if I look, I have a positive 3 divided by a negative really small number, and that will be a negative infinity. And that limit is evaluated. For this one, I'm again just going to plug in. That is the first step. So I'm going to say that this is 6 times negative 1/2 squared minus 1/2 minus 1 over 4 times negative 1/2 squared minus 4 times a negative 1/2 minus 3. And I'm going to clean this up a little bit. So we'll say that this is the negative 1/2 squared is 1/4. I'm not going to clean it up too much, but I'm going to say, okay, so this is 6/4 minus 1/2 minus 1. I'm just getting rid of some parentheses. Negative 1/2 squared is 1/4 times 4 is 1. And then negative 4 times a negative 1/2 will be a positive 4/2 or plus 2 minus 3. Okay, I'm going to clean it up a little bit more. This is 6/4 minus 1 minus 1/2. That's a negative 3/2 right here, so minus 3/2. And then in the denominator we have 3 minus 3 is 0. Okay, so 6/4 and 3/2 are the same fraction, so this is 0 over 0, which means I have a removable discontinuity. So what I'm going to do now is actually factor, cancel the factor, and reevaluate the limit. Now I actually already know what the common factor is, but if you can't look at this and tell what would make, what factor would give you this as an answer if you set it equal to 0, then you're just stuck factoring for a little bit. So I know that my numerator is going to have 2 factors, it's quadratic, and so is my denominator. So I have 4x squared. The first thing I'm going to try is a 2x and a 2x. And my clue there is I'm dividing by a 2 here. I look at here, my last numbers in each of the factors have to multiply to 3, so that's a 1 and a 3. If I look at my middle term, when I multiply these, it's a 2x. Multiply these, it's a 6x. 2x minus 6x is negative 4. So here's a negative, here's a positive. And this is actually my common factor, because if you take that 2x plus 1, set it equal to 0, x equals negative 1/2. And there's the 0 that's creating this problem. We plugged in negative 1/2 and we got 0 over 0, so negative 1/2 is a 0 to both of these. So 2x plus 1 is the common factor, and I'm just going to go ahead and put that in the numerator as well and show that it works out. So 2x times a 3x gives me the 6x squared. And then this 1 means 1 times 1. It's a negative 1, so I need this to be negative. So if I multiply this out, I have 6x squared, the negative 1 out there, but I have a 3x and a negative 2x that gives me the 1x, and it is factored correctly. So I can cancel my common factor, and I'm going to take the limit again. So I'm doing the limit as x approaches a negative 1/2 from the right of 3x minus 1 over 2x minus 3. I'll take the negative 1/2 and plug it in. So 3 times the negative 1/2 minus 1 over 2 times the negative 1/2 minus 3. This is a negative 3/2 minus 1, so take away 2/2. 2/2 is the same thing as 1. So negative 3/2, take away 2 more halves, that equals a negative 5/2 over 2 times the negative 1/2, that'll be a negative 1 minus 3, so negative 4. you could rewrite that. This is this 4 actually comes in here because you have negative 5/2 times 1/4. That's the same way to actually write this. Divide by a negative 4. Sorry, negative there. Negative and a negative cancel out, and I have 5/8. That would be my limit. For this problem, if I plug pi over 2 in on my unit circle, I know where pi over 2 is. It's up here. Cosine is the x value. So I know that cosine of pi over 2 is 0. So this equals a negative 2 over 0. Again, if I do a number divide by something really, really small, I get something really, really huge. So I know that this is going to involve an infinity. The question is it positive infinity or negative infinity? If you look at your limit, you're coming at pi over 2 from values more than pi over 2. So this is 0 over here, this is pi over here. So if I'm using the unit circle, I'm actually coming in this way. And I'm taking the cosine of these values as I'm coming in. So cosine is the x value, so these values are actually negative because they are to the left of the y-axis. So this would be like a negative 0. A negative divided by negative is positive, and so my limit is actually infinity.